Okay, so we're going to basically work out here what the graph of a sine function looks like and what the graph of a cosine function looks like. Now, the worksheet says y and y equals, but don't forget these are a function. I don't actually like us using y there. This is a function of an angle. A function of an angle. It's better to use that, because otherwise it's going to get very confusing what we mean by y. Okay? So when we're graphing these, the x-axis is not x's, we're graphing angles. And what we normally think of as the y-axis is not y's. This is the function of the angle. Yeah, the function axis and the angle axis, theta and function of theta. Right, when we're graphing a sine, we know that sine is a y divided by an r. Do you see why I don't want to use y there? Now, if on this circle, if I say that this is scaled so that the radius equals 1, this would be y divided by 1. So it's just the y coordinate of any point on this circle is going to give me the sine. So if I took an angle, like this angle here is pi by 6, you know that angle there is pi by 6, the length of this vertical line here, its y coordinate of that point, is going to give me the sine of that angle. So where to graph this? Look at the scale on this graph paper. Here is pi, and it's made out of 1, 2, 3, 4, 5, 6 lines. So each square there is pi by 6. This would be 2 pi by 6, which is pi by 3. This is 3 pi by 6, which is pi by 2. This is 4 pi by 6, which is 2 pi by 3. And this is 5 pi by 6. 6 pi by 6 is pi, 7 pi by 6, 8 pi by 6, 9 pi by 6, 10 pi by 6, 11 pi by 6, etc. And these dashed lines, you'll see that it's halfway to pi over 2. That's your pi over 4. So this one would be 3 pi over 4, this one would be 5 pi over 4, and this one would be 7 pi over 4. Okay. So get any sort of piece of paper you like and just use it like a ruler. Line this up carefully with the x-axis on the graph, and you're trying to measure the length of the y coordinate, and this was for the angle pi by 6. Then come up to pi by 6 and transfer that line there. It's been done for you. Now for the angle 0, look, this one's y coordinate is 0, so you've got a point here. Now let's have a look at pi by 4. That's the angle pi by 4. So here is its y coordinate, and that's going to represent the sine because our radius is 1. So come over here to pi by 4 and graph that length. About there. Okay, it actually should be a little bit, that would be 0.75. It's actually a little lower. These lines here are cheating and tell you how high to make them. And then we want to do pi by 3, and here's the angle pi by 3 to this line here. Okay, that one's y coordinate. Measure it there, and pi by 3 is here, so put that point on here. Okay, and keep on going. Don't forget, this is an angle. This is for pi by 2. You're going to need that line. And then think about it. When you come down, say, let's do this one. 7 pi by 6 here. This y is negative. You'll notice it's, oh, I should have done it in green, so it matched with the same reference angle. This is for 7 pi by 6, but you're going down. So for 7 pi by 6, you're going to do that length there going down. When you're finished, get these points and neatly draw them up, and you're going to see why we call the graph a sine wave. When you finish the sine one, now come and do the cosine one. Now again, if the radius of the circle is 1, cosine is normally an x divided by an r, but if your r is 1, it's just going to be the x coordinate for any of the points on here. So here is the angle pi by 6. The cosine of this angle is represented by that horizontal length. So get your piece of paper, mark it off, that length. Now, that was positive. Going in this direction is plus, going in this direction is negative. If I'm going plus when I'm putting on this graph, that means I draw that line going up. And you'll see that first one has been done for you. And in actual fact, we've also got 0 done for you. Look at this. There's the 0, the angle 0. This is 0 or 2 pi. So 2 pi, that's going to go at the end there as well. That's also going to be going up there. Yeah. So keep on doing these. Don't forget this one's going to have an x length of 0. When you get all your points, draw them together. Oh, let's do a negative one. Let's do 7 pi over 6 again. So 7 pi over 6 is here. Its horizontal distance is there. Yeah. Normally we draw the triangle like that, but that horizontal distance is the same. It's just easier to measure it there when you're measuring with a piece of paper. And so this was for 7 pi by 6, and we were going to the left, so it was negative. So when we get to 7 pi by 6, which is this one here, that's 7 pi by 6, we have to go down. And you'll notice as you're doing this that there's only a very, very limited, oh, good grief, it should be actually there. Oh, my graph's not working. No, it shouldn't be. It should be there, thinking about it. Sorry, muttering away to myself. Okay, so when you see this, you're going to see a wave that looks a little bit like this. Once you've done it, submit it. Do answer all these questions as well before you submit it. I hope that made some sense, and you'll see what we're going to do with these pictures of these waves on Wednesday.